There we go. Good evening, all. And welcome to tonight's TI Technology webinar hosted by Texas Instruments Australia. We are really excited to bring you Exam Readiness General Mathematics Stage 1 for SACE with Isabel Hoadley and myself, John Baymans. Although it is SACE, a lot of this will be applicable to other exam boards, whether it be Queensland, IB, and others around the country and around the world. So thank you for joining us this evening. So as I said, my name is John Baymans, and I teach mathematics to Year 7 to 12 students at Lachlan Catholic College in Darwin, where I use TI technology to help students make stronger connections in their understanding of mathematics. And more importantly, I'm excited to introduce our other panelists this evening, a fellow teacher of mine, Miss Isabel Hoadley. Good evening, Isabel.
Hi, everyone.
Now, we did a webinar together, Izzy, on Tuesday for methods, and I called you Isabel then as well. So, sorry, Izzy, good evening.
That's all right. I don't think you have to keep saying you're excited to see me as well every 2 days.
I am. I love doing webinars with you. You're fantastic. You know, you're knowledgeable, you're enthusiastic, and I love the way that you share it with your students. So I am excited to be with you tonight.
Oh, that's a relief.
It's only anyway. As you can see, Isabel is also a teacher at Lachlan Catholic College here in Darwin. She's very enthusiastic in the classroom, and she's definitely dynamic. I have to admit that her biography that you can see there is fantastic and is justified. Her professionalism that she shows in her teaching and the respect her students have for her is first class, so that's fantastic. So thank you for joining us, Izzy.
Pleasure.
For now, let's get started. So as you can see on the right-hand side of my screen here, I've got a TI Smart View, which is a simulator of, well, not a simulator, it's actually an exact copy, just a computer version of the handhelds that the students have. Hopefully that you've got one of those that you use in your classroom. I use it with mine, and I have a smart board, so I actually touch the screen and actually touch the keys, and the students know exactly what buttons I'm pressing. I'll enlarge that later, and so will Izzy, but I'm just going to show you to make sure that you've got the current update. So on all operating systems, no different to our phones or tablets, even smart TVs, we did have them the updated OS. Whether you've got the 84 Plus CE or just the 84 Plus, to find what you've got, press second men. Oops. There we go. Go to About, and it will tell you here what operating system is. And this is the current one for operating system is. And this is the current one for the 84 Plus, and there's a current one, I can't remember off the top of my head, I used to, for just the 84 Plus. Now this is for the Smart View, and we do the same on the handhelds. If you need to update them, the easiest thing is to go to the TI Australia website. You can see here there's an icon here to click Update. Let's go Update again now. Choose what you're going to update, whether you just want to update the handhelds or your emulator software as well, and equally the hubs. The hubs now work in the rovers, the vehicles. If you don't know about that, please find out a bit more about it or watch some of the on-demand webinars. So we can update all of those, and we go to Next, and we can download everything. We need TI Connect to actually make a connection between the calculator and the computer. So that looks like that icon there on the side of my screen, as you can see. You need to download the OS and all the apps bundle. So that looks like that there when it's downloaded. If you're on the Smart View, there's the updated Smart View here. So I think mine's on there just behind this screen here. There it is. There's what it looks like. And if you want to use the hub, you need both the software and the sketch, and that is this one and that one there. All right. So when you go to TI Connect, and then you connect your calculator, you can see I've got a calculator connected now, and it already tells me that it's on OS 5.3. If it wasn't, then I can update it by simply grabbing the document and dropping it on top, and it'll update the OS. Easy as that. I'm not going to do that because it's already on the updated OS. The other way that students can do in the classroom, if you don't want to do it for them or you want them, they can actually share it between each other using the link section. Now, I can't actually show you that on the emulator because it won't click on link. There's nothing to link to, but I can show you some screenshots I took today on my handheld. So you would click second link, and you'll see this screen. If students are going to receive it, they would go arrow across and press enter here. Don't forget, you've got to use the mini USB to mini USB cable. Students who are going to send it would arrow up or scroll to the bottom to send OS, and then just press enter. It is that simple. So they can share the OS between calculators, as long as they have the mini USB to mini USB. And now, Izzy will show you how then we use all that with the students. And then we'll come back to me, and I will do some stuff on TBM Solver or the financial math before we finish up for this evening. That's great, Izzy. All yours.
Beautiful. Okay, cool. As Jen said, we're going to be kind of focusing on different elements of the general maths course this evening. The three topics that are examinable are statistical modelling, financial modelling, and discrete modelling as well. So I'm going to focus on statistical, and John's going to focus on financial, and they're the two kind of biggest technology topics that we look at in general maths. What I have here is, this is just a list of some of the different concepts that are given to us by the SACE board in terms of what we want students to understand in statistical modelling. You should be able to see that it's broken into kind of two parts. The first part is focusing on bivariate statistics, second part on normal distribution. What I have on the other side is just how we can kind of use technology to enhance students' understanding of that. So with our bivariate statistics, we're mostly looking at finding regression models and also plotting some residuals and making predictions based on our X and Y values. With normal distribution, we're looking at finding proportion, inverse normal, and I'm also going to show you how to draw some graphs of normal distributions on the calculator as well. Okay, so moving on. The first thing that students need to do when they're starting their exam is ensure that the calculator is in the right mode. So if we go to the mode button, we want they probably for general want their calculator to be in degrees. There isn't necessarily going to be any question that involves them to do any trig or use degrees in their exam, but it is considered assumed knowledge from stage 1 general, so we can't completely rule it out. So I would suggest they have their calculator on degree mode. And the other thing that we definitely want them to do is make sure that they've got their stat diagnostics turned on. If they don't have it turned on, like I don't here, they won't be able to find their R and their R squared values for their regressions. Okay, so once we've done that, we're going to look at the first problem, which is looking at the weekly closing price and percentage yield of shares of a certain company. So I already entered this data into my list one, but sorry, I'll show you how to do that a bit slower. So we go into Stat, into Edit, and we have our list editor up on the screen. A couple of things that students might accidentally do, which is going to hurt them in an exam when they're trying to do a question like this. The first thing is a common mistake students do is they go and they delete a single piece of data from their list, but in doing so, they may accidentally delete an entire list. So if they want to clear a list, they have to use this clear function. If they use the delete, they're going to delete that entire list. So I'll do it here so we can see. So now we have no list 1 in the list editor. If they want to get it back, it's really easy. They just go second, they press that same delete button, which is our insert function, and they'll get their new list back up again. We then want to name it list 1 again, and we should see that same data that we had already in there before, which we do there. If they want any other lists other than the list 1, list 2, list up to list 6, which you can see on the 1, 2, 3, 4, 5, 6 keys, they can go second, list, and they have all of their lists included in that menu there. What you should see here is we've still got that piece of data that I deleted from earlier. So with that piece of data, if they try to do any calculations with an uneven number of data in their lists, for example, if we just want to calculate our one variable statistics, we have our list 1 and our list 2, and if we go to calculate, we're going to see a dimension mismatch, and students won't be able to receive any information from that. If we go down to go to, we can see that in our list we've got a dimension mismatch, and we go into edit, and we can see that we need to re-add in that piece of data that we had before, so 32.5, 34.52. Okay, the first part of this question asks students to sketch a scatter plot So to sketch a scatter plot, once we've put our data into our list 1 and list 2, we go into second, we press the y equals, which is the stat plot function, and we're going to look at our plot 1. We want it to be turned on, which it already is. We want a scatter plot, and we want to make sure that our X list and Y list correlate to the same X list and Y list that we input our data into. So we're going to change that. Second 1 will give us list 1, and second 2 will give us list 2. The next thing that I told my students last year that they always had to do is they weren't allowed to go from the Y equals screen straight to the graph screen. They had to go into window first and set up their window accordingly based on the data that they're given. So in here we can see that our shares are approximately going from about 25 to 35, but we're going to add in a little bit of margin of error, and we're going to go from 20 to about 40. And I'm going to set up my Y from 0 to 7. And I'm just going to change my scale. I had it set at 0.1. I'm just going to change that to 1 as well. Once they've set up their window and they graph, they should see their scatter plot on the screen. The next thing that we probably want to do from here is calculate our regression. So we want to always probably be using the AX plus B regression, not the A plus BX regression. That's really important. SACE mostly will call for your linear equation to be written in this form. So if we go into our regression, again, we want to make sure our lists are the same. So I'm going to change my Y list to list 2. I want to store the regression equation. And the easiest way for students to do this is to use the function keys. So we're going to go alpha F4. That brings up all of our Y variables. And I'm going to store my regression in Y1. Into calculate. And here we can see our A and our B values and our correlation coefficients. One thing that the Chief Examiner's report did bring up from last year was students were really bad at interpreting what their A value was actually telling them. So that might be something that teachers might want to focus on in the lead up to the exam. Now if I go into my Y equals, we're going to see that that has stored into Y1 that equation. And if we graph it, we can see our line of best fit through our data. The next part that we want to do is we've already calculated our R and our R squared values. We want to describe the relationship between P and Y, remembering that students need to not be using X and Y in their equations if they're given other variables to use. So they need to write their equation in terms of P and Y. And we want to look at our residual plot. And this is a new part of the course, which wasn't done particularly well last year. So another thing that I got my students to do was when they're doing their residual plot is to also enter the residual data. And I think this is important when it comes to, say, for example, setting up their window so they know what kind of values they're going to expect. So in list 3, I want to find what the residual values are. So we're going to go second and list. Sorry, press that twice, second and list. And if we scroll, you can either go up to get to the bottom or we can go down to get to the bottom. I'm going to go up because I know the residuals towards the end. And I'm going to select this list, which is resid. And that'll use the regression that you've just done and your Y values. And here we've got our regression. If we go into stat plot and we want to see what that looks like, again, second Y equals, we're going to look at plot 2. Again, I want to turn it on, make sure it's a scatter plot. I want to use my X list is the same as before, so L1, and I'm going to use my Y list as the residual. And again, I noticed before that my Y minimum is slightly negative, so I'm going to set that at -1. My Y max I'll keep at 7 so we can see both on the same graph. And we can see there we have the residual plot. Hopefully you can see from here you've got a fairly non-uniform distribution, which is indicating that our linear model is the correct one to go with. And quite often when SACE are asking if a linear model is appropriate, they're wanting more than one piece of evidence. They want to know what the residual plot looks like and the trend in the data. They also want students to talk about the R and the R squared values as well and how close they are to 1. So they're really after 2 things when you're discussing that. Another thing that I find it handy if students can do is just setting up their graphs so they can see those values in the data alongside their graphs as well. So to do that, if we go back into our mode, you should be able to see here we've got a full horizontal and graph table function for the way that we want to look at graphs. If I want to see my data at the same time, I'm going to select Graph Table, go back into Graph. I'm just going to make the screen a little bit bigger so you can see. And here we can see our data that we originally inputted, that's from our list 1 and our list 2, alongside our scatter plot. If we want to look at, say, for example, the residual data, we can also do that as well. We go Second, Graph, and that selects the table function. And if we just tab across to the right, we can see that we get our list 1 and our residual. And if we tab across again, we get our X values and our Y values as well. And so that lets us predict things from our line of best fit. We can change the scale for the table by pressing plus. At the moment my scale is 1, but if I wanted to see it a little bit smaller, I'll set it at 0.5. We can see that that changes our X scale as well. The last thing that students have to do for this question is they just have to make a couple of predictions of their Y value based on their given X values, and that's at 31.25 and 23.52. So these values aren't particularly useful for looking at a table and looking at, but if we had whole numbers, we could probably use that table and predict the Y values off there. To predict our Y values, the next easiest way of doing it is going Second, Calc, selecting the first function, which is value, and this will tell us a Y value for any given X value, and we can chuck in 31.25, and we get our Y value of 5.27. Again, for the next one, we can put in our X value of 23.52, and again, we get our corresponding Y value there. That was one thing that SACE commented on, that the Chief Examiner commented on in the report, was that students did really well at determining values when using technology. They tended to make errors when they were trying to solve equations. So probably the feedback from last year is that it's good if students can use technology for their problems. Okay, I'm just going to quickly reset my calculator and we'll look at the next problem. Okay, so the next thing we're looking at is an exponential problem, and we're looking at the size of a population of people aged over 65 for 100 years. We're given the values at the end of each year, and the first thing we want to do is find the model which best fits the data. But we're going to use t equals 0 to represent 1896. So we don't want to, when we're putting our values in our list, we don't really want to have 1986 there. We want to use t equals 0. There's a couple of ways that we can get the calculator to work with us on this. The first thing is you can perform calculations inside the list editor. So if we did 1896 minus 1896, that's going to give us time equals 0. And we could do that for all the data, but it is quite time consuming. So if you just give me a second, I'm just going to enter these. Okay, so there's our 9 pieces of data that we've inputted, and we've put that into list 4. I want to put my X values into list 5, and I want to subtract from all of those list 1 values. I want to subtract our original starting time, which is 1896. So this is going to take 1896 away from all of those values. Oh, sorry. I did list 1, sorry. List 4 minus 1896. Sorry, I guess we're used to putting everything in list 1, and there we go. There's our years that have come up there. For our population, okay, there's our population data as well. Again, we want to create another stat plot of this data. So I'm just going to delete what I previously had in there. I'm going to turn my second stat plot off. Again, you can just turn it off by highlighting the plot 1 and 2 on and off. I'll show that in a second. But if we go into our plot 1, again, we want to start a plot. In this case, we had our X list was in list 5, and our Y list was in list 6. We're setting up our window this time. It's going to go from 0 to 100. And our Y min, we'll set that as about 0 to 2,000 for the moment. Okay, we can graph, and we can see we get a fairly exponential trend in our data here. We are going to calculate our regression, and for this question, we're going to use the exponential regression. Make sure that students use the exponential regression, again, rather than the power regression. That was another common mistake that seemed to be made. So we want to use our exponential regression. Again, we're looking at list 5 and list 6. In this case, I'm going to store my equation in a different Y variable this time. We're just going to chuck it into Y2 and calculate. And we can see we get a really nice high R and R squared value, and there's our regression line. In Y equals, we can now see that's been dumped into Y2. If we go back to our graph, we can see our regression, and we're going to use this model to predict a couple of things. So the first thing is we want to predict the population in 1960. So we're going to go to calc. Again, we've given an X value, we're finding a Y value, so we can use that value function, and we can also still do those same calculations that we did in the list. So if we're looking at 1960, we want to take away 1896 from that, and we can see when X equals 64, Y equals 761.5. The second part of this question is a bit more complicated, and this is where students really benefit from having the technology so they don't have to rearrange their equations. So we want to know in what year over 65 would our population reach 2,000. In our Y equals, I don't really like the black colour, so I just want to change that to, it's one I haven't used yet. We'll change it to light blue, and we're going to make that equal what Y value we want to find out, which is 2,000. If we graph this, we can see that we don't really get a clear point of intersection, and that's because the window isn't set to the right to a large enough value. So again, we want to go back into window. I'm going to set my X max to about 120 and my Y max to about 2,300. And from this, we should be able to see a really nice point of intersection between our two lines. To find that point of intersection, again, we use that same calc menu. So we go second, trace. We want to look at number 5, which is our intersect. And students always just have to press enter 3 times, once on the first curve, once on the second curve, and once around about in the middle. So we're going to go once on the first curve, once on the second, and then move our cursor until we kind of guess the point of intersection, enter again, and we can see that we get our intersection where our X value is 101.9, our Y value equals 2,000. So that's the year after 1896, where we would expect our population to reach 2,000. Okay. The last thing that I want to look at tonight is just some normal distribution. So with our normal distribution in general maths, we're mostly focused on finding a proportion or a percentage, finding quantiles, and the last thing would be comparing 2 different normal distributions that might have a varying mean or a varying standard deviation. So to find any kind of proportion or percentage, students are always using the normal CDF function. The only time they really use PDF would be for graphing, which we'll go through in a minute. So in our normal CDF, they should be familiar with the fact that if they're looking at their very lowest extremity, they're using negative E99. If they're trying to find the a very highest extremity, their upper value is going to be positive E99. So in this case, I want to find my proportion of marshmallows which are greater than 14.1 grams. And because we're looking at greater than, we need to be using positive E99 for our upper limit. The mean is 13, standard deviation of 0.75, and I can paste that, and I get my proportion as 0.712 or 7%. The other thing that we want to be able to do for normal distributions is to calculate our quantiles. So in inverse normal, if we know an area, and remembering that students can, if they're given a percentage, they can input their area as 12 over 100, and that will still give a good result, or a 0.12. Again, we know our mean is 13, and our standard deviation is 0.75. And in this case, we want to know what our the minimum weight of our heaviest 12%. So in that case, again, always get students to draw their normal distributions and shade in where they're trying to find it. But if we're looking at our heaviest 12%, that's off to the right here. So we're going to use the right part of this function. If we paste it, we can see that the minimum weight of the heaviest percentage is at 13.88 grams. I just want to show this using center, so I'm going to use those exact same values again, but instead we're going to look at our middle 12%. So we're going to use the center function, and you can see we get two values for the center. So our middle 12% would lie between 12.87 and 13.11. Okay, the last thing that we want to be able to do for normal distribution, and these kind of questions come up really often, and this was actually taken out of last year's sample exam, is we want to be able to compare a couple of different normal distributions and sketch them on the same axis. So if we want to draw any kind of normal distribution, we go second, distribution, and this is the only time that we're really going to use the PDF function. In PDF, we want our x value to remain as x as a variable. We want our mean and our standard deviation to stay the same. And we're going to paste that into our y1. In y2, I want to put our comparative normal distribution. So again, we're using PDF, x stays as x. And for this one, we're comparing where we've got a standard deviation of 0.375. Okay, again, we paste, oh, I just deleted that. Again, we'll just paste that in there, and we can see we've got our two normal distributions with a differing standard deviation. What students should be aware of here is that they need to be really careful about their window. We obviously don't want a Y maximum of 2,300. I'd say 1 is usually a good maximum for students to set it out, and then they can just kind of test and adjust from there. I'm going to set my Y scale as 0.1. And I want in this case, they should also be familiar with their standard deviations and how far they should set their X scale to. So in this case, I'm going to set my X scale from about 10 to about 17. And that should show the whole normal distribution. If we go to graph, we can now see that we have our two graphs of our normal distribution, and I was just slightly off with the Y max. We'll make it 1.1 instead, and we should be able to see the top of that graph there now. Okay, all right, I think, yeah?
I used that with my year 10s today, actually. There's a section in the year 10 work that I was doing, and I was using Add Maths year 10s, and they have these calculators, and they were interested in the standard deviation and what effect it has, and it doesn't mention it in the textbook, just talks about the width of 95% and 64 or 64%. It doesn't say anything more. So I thought, oh, this would be great. And they thought that was the coolest thing. Once they saw that graph, they really liked that visual, and I think it really implanted in them what actually what the mean is and how many standard deviations are to the side. So I think it's a great little thing, and especially if you set that X scale to match the 3 standard deviations, it looks really great, doesn't it?
Yeah, it's really good. I look at it as well with the year 12, where we're connecting normal distribution to integration as well, and we look at how we can use the integral calc to find those kind of same proportions, or at least similar proportions. So I think in all year levels of maths, it works really well, especially because I find that standard deviation it's not a concept that students really understand unless they have a visual like that at all.
I used to use, in distribution, you can obviously do draw. You can do normal CDF draw. And I used to use that quite a lot. But the only downside of draw, though you get a visual with the areas, the downside is that it's only a draw and it disappears when you do something else to it.
Yeah.
Okay. Anything else, Julie?
No, I think I am done.
Well, thank you very much. All right, so back over to me. And now, thank you, Izzy. I'm going to bring it home by looking at the financial side of it. And as Izzy mentioned as well, we looked at hopefully you guys have looked at it as well, the subject assessment advice from 2017. This is sent out by the chief examiner via SACE, and it's really interesting to read it. These are the general comments of finance, and there's 5 of them compared to only 1 for the component that Izzy's just shown. This is a really vital one. If students get an answer that doesn't make sense, if they just ignore that and just leave that number that doesn't make any sense, like, I don't know, a negative time, they're not going to get any marks for it. But if they can write a comment, like they mentioned here, then there's more of a chance that they would get some marks for it and they could get follow-through marks. So that's really important. Number 2, the second one really surprised me that was the case. There's quite a few students that don't know how many weeks there are in a year or fortnights. So a couple of different ways you can do that. I like the number of cards in a deck of cards is 52 as well, but they've got to remember that there's 52 cards in a deck as well, so that doesn't help sometimes. But this quite amazed me that it varies this much. Moving on to some more ones, we're going to talk about what the signs should be on principal value, the time period values, and the future value. And again, here they mention about getting a negative for the M. And this is what we're going to focus on, is the TVM solver on the graphics calculator, and how important that is that they use that. And the last one is writing these numbers down and being careful when they write those numbers in. Again, I'll give you some hints on what I think is the best thing to do, but these are the general comments from the SACE board. So if they say that, then I think it's worth taking them on board. That is available on the SACE website if you didn't know, and we can always send you those links. So I think that Izzy already mentioned about resetting the defaults. Izzy, you did mention that, didn't you? If you didn't, then we go.
Yep, sorry, yeah, no, I did, yep.
Yeah, I thought you did, so I don't need to go through that one. And we're going to start here. So, TVM solver. I think that the biggest thing that is the problem for students when they go to TVM solver is that there's already normally numbers in here. And with those numbers already in there, they get confused which ones they've done and which ones they haven't done. So I always encourage my students on each question, down the side of the question they're doing, to actually write the sort of variables that they've got, the unknowns that they've got, and write them all in. This I find the most useful. Now, SACE, I don't think necessarily mark this because this is calculator speak, but at least it gives them some idea of what the students were thinking, and at least it's not going to hurt, at least. It also allows students to see what numbers they've got, and then obviously all these equals should have a number next to them except one that they're going to solve. The other way to do it is to set it up with zeros like I've shown you here. So there's 2 ways of doing it. Just remember what these mean, and I always find that doing n last is the most easiest way to do this. Because n is not the years, which students sometimes think. It's the number of payments. So it's always easiest just to be that whatever you've worked out to be p/y times the number of years. So whenever you get this number down here for your payments paid per time period, that's what this will be up here times the number of years. So I normally do n last. That's what I recommend to do. The interest rate, obviously when they've used to, sometimes using interest rate, they may do it as a decimal. In here, it's as a percentage, so make sure they don't forget that. The principal value, how much they invested originally or how much they borrowed originally, how many payments they're making per time period, and the future value. Obviously, if there's a saving, it's likely to be what total they're after, the goal they're after, or if it's a loan, then it's down to obviously trying to get it back to zero normally. And SACE are normally pretty nice, but these 2 numbers are normally the same. They can vary, but normally they're the same, so we don't have to worry too much about either of those. But obviously, P/Y is the payment period, and C/Y is how often the interest is getting compounded, which really doesn't make sense that it's going to be compounded every fortnight, the same as say the payments, but that's what we're going to roll with. So I think that what I'm trying to say with these values, this is the easiest thing I say to students. And Izzy, I'd be interested in the way that you teach it to the students. But for me, I say that if they're giving it to the bank, if they're getting rid of it, whether that be in a payment or whether they're putting it into a savings account, then we put it in as negative. And if they're getting it, so if they get it out from the bank, from the loaning company, so they're getting a loan, or they're getting payments out from savings, then it's a positive. Izzy, do you teach it like that, or is there a different way that you explain it?
Yeah, that's exactly how I explain it. So if they're giving away money or if they're putting money into something, it's going to be negative, and if they're getting it back, then it's going to be positive.
Yeah, cool, excellent.
Yeah.
Nice to be on the same page. So these are from SACE exams from last year. They are on the website again for you to use for either, not so much a trial exam for students, but definitely a practice exam, and students have access to that. Also, the MASA, the Maths Association of South Australia, they put out a revision guide, which I would highly recommend, and that not only has the paper in it, but has their version of the solutions. So these are going to be my version of the solutions tonight as well. When I get students to read the questions, I definitely recommend with these questions to highlight things. They sort of have plenty of pens to take into their exam with them, and they seem to sort of stay away from these. But I really recommend having some highlights, or I think highlights are better than underlining. Somebody talked to me the other day about actually crossing out what you don't want. I'm not sure that would work in this case, but maybe. Because if you cross out the wrong thing, then you really are scuppered. But let's look at what's important in here. We're going to make fortnightly payments, so that's a payment. We're making that payment. Okay, so we're depositing that, so it's going to be a negative. Into an account that pays an interest rate of 3.45%. It's compounded fortnightly, and it's paid fortnightly. So there we go, there's that double link. It's got surgery in 5 years. How long will they have in this account? Up to 5 years. So now we go to here, we start with no money. It's 5 years, so that's 5 years times the principal value, the payment per year, which is 26. That's a nice way. You don't have to worry about calculating that. Nice way to do that rather than actually getting the students to calculate somewhere else or try and do it in their heads. And then how much will they have in their account at the end of that time? Alpha solve, and there we go. 9,145 and probably 5 cents is probably better, or 0.04 cents. Again, I get the students to write down the whole number and then write approximately equal to how many dollars. The next question. Then they want to pay for his savings. In order to calculate how much longer they'll have to wait. So how much longer will they have to wait? Okay. Well, there's 2 ways of doing this. The first way, I suppose, is to say, okay, we want the future value. I want to take out from them at the end of that time $17,000. So how long will it take me to get that money in total? For solve, it will take me 226 fortnights. And then at the end of that, I could then go to the end of that number and take away. Because I find that, yes, they should know what that number is, take away 130, but why not get the calculator to help them and support them just in case? It's silly to make some careless errors. Again, write that number down in their answer, which is approximately 97. So that's one way of doing it. I want to just show off another way, a way that you may not be aware of, and that is, so we do go back to the original. Well, that value there, that's our future value. In 5 years, if we keep going, that's going to become our present value. So now, we could get the students to type that in by hand. I'm always looking for a quick way to do questions. So we can go into apps, back to finance, and I don't know if you've noticed, but rather than going to calc, we go across to vars, and there's future value. So that will dump the future value into where the present value is. And I like that visual. It will quickly turn it to a number, but that's quite nice. It's already in the bank, so I don't have to worry about changing that to a negative. It's just in there. I'm not giving it to the bank. It's already there in the bank. And we're going to then say, well, okay, we need it still to go to 17,000 and solve that question, and it will search away. Whee! Oops, no, I've given it to the bank. Silly me. I've given it to me, so here we go. Second insert. Oops. Let's try that again. Second insert. Negative. And what was the number before? 9,000. Of course, I've given it to the bank, so it's got to be a negative. And alpha solve that, and there we go, 96.16, which we know is 97 fortnights. Important that the students write down fortnights. And, of course, I gave it to the bank, so that was a bit of a careless error on my part. All right. So this is a classic question with inflation. Sometimes students get out of that and do it in a normal calculator screen, but we can do this question just the same in the calculator screen. How do we do it in the calculator screen? Well, it's 12 years. The interest rate is 2.8. I shouldn't have done N first. I said not to do that. I said to do that one last, but there you go. We start with the money in there, which is 17,000. We're not making any payments because it's just inflation. It goes up. There's no inflation, but it's compounded per year because that's what inflation does. And alpha solve, and that's how much 17,000 will be worth in 12 years' time at an inflation rate of 2.8. I quite like doing it in this screen because then the students don't have to get out of that screen. They haven't got to remember something else to do. It's all wrapped inside there. Is there a different way that you do that question?
No, that's how I got my students last year to do it. And we did do it by hand first, so they could kind of see the connection between compound interest equation and inflation. And then we talked about how we could do it on the calculator, and they preferred that a lot more. And they found it made a lot more sense being able to do all compound interest equations using that formula.
Yes.
Or using that program.
Yeah, it does make it easy, doesn't it?
Yeah, yeah.
Okay, so we now, things change, and notice I like SACE how they don't have the questions too linked to each other, so although the concept is linked, they give you some new numbers, so students haven't got to panic about, oh, no, I didn't get the last one, so I can't get the next one. It's a skill we need to teach them to be resilient then, to always looking for more marks in other questions rather than go, I can't do the start of this question, I can't do the whole question. It's really important that we develop that with it. When I do practicing with my students, I sometimes even get them to do part D before they do the rest of it, so they get into the mindset of, okay, this is a standalone question, I can do this one, or standalone part, should I say. All right, so they have so much left in their savings account. All right, they're going to invest that now. I thought I made some colours on this one. I've obviously missed my colours on this one. So they put it into an invest, so they give it to somebody to look after for them, so it's a negative. And it's invested into an annuity, pays 5.7% per annum, and it's compounded weekly. Okay, and nice, they want weekly income, so that makes life easier, 52, number of cards in the deck of cards. Expected annuity to last 10 years, so back up here now, 10 years times the P/Y 52, that makes that easy. And what are we working out? Calculate the weekly income, so that's going to come down to how much is he going to get? I think it's a he. Alpha solve. Didn't change the number. Aha, where's he gone wrong? Future value. And now you can see what the error is of not clearing these again or not having that screen where, and I showed you earlier, let me just go back to this one and escape that for a second. Not having something set up like that, because I naively forgot that this number had to be 0, because obviously at the end of that time he's going to have no money left. So this approach really works well, rather than just randomly changing numbers, because they're likely to miss one, like I did. There we go, 246. There we go, back to the screen that we're on. I can't. Come on. There we go. All right, question 5. Here's the next one. So with question 5, this is that classic one where we've got to work out the effective interest rates. So we aren't going to do that in this screen this time, and there's a very quick way. This question was worth 4 marks in the exam, and even the examiner's report talks about in this question that students could have done it using the effective function rather than a much longer way to do this question. The account 1, well, that's fairly easy to do for effective rate. We go into apps, back into finance, and we aren't going to use TVM Solver this time. VARs is still there, notice. We're going to go to effective rate, which is C. And effective rate, now, they've only got to remember the syntax, so that would be on their cheat sheet. They're allowed a cheat sheet to take into the exam, so I'd have that written down. And the effective rate is the interest rate and the periods per year. So 3.8, comma, 12. And there we go. The effective interest rate, the APR for account 1 is 3.87%. Now, let's do the same. I'm going to copy that one down just by arrowing up, and let's delete those numbers and let's type the numbers. Can I do this one for flat interest rate? Well, yes, I actually can. The interest rate this time is 4. Now, what would the time period be? Well, it's flat interest rate. So if it's 2 years, that's really a half, because we've got to put it down to 1 year. So we could just type it in as that. And there's the effective interest rate for account 2. Therefore, account 2 is better for return, and then there's your support as well, that you'd write that down at the effective rate. So a much quicker way to do that. So what does Hassan decide to do? Well, instead, Limey changes his mind, which obviously he's done that because then students don't have to worry about knowing anything about the last question. They can go straight on to this question, which pays 6.3% weekly deposits. Okay, so show that you'll have earned. Now, I'd like to talk to students about why is it a show that question. Right, that's really important to me, why it's a show that question. Well, it's a show that question because we're going to need this answer in the next part. So again, maybe we get them to do B2 when they're practicing first before they do B1, because they don't need to know how to do this. They don't need to freak out and go, I can't do this, I can't do this. They may not be able to do this, but they can still do this question. So I think that's important that we do. So what we're in this screen, let's just do that. Calculate the amount that we'll pay in tax. Okay, so that's 32.5. Well, let's do that as a percent. There's a quick button now on the US, which is alpha x, to make it into a fraction, percent, quite like that, times the amount of money, 860, and there we go. We're going to pay that much in tax, 279.50 in tax. Now let's go back to do B1. We're going to go back into TVM solver. All right, so let's go back to the approach that I said that we should use, and I didn't, and made myself look a bit silly a minute ago, and let's go back to setting more like that. All right, so he doesn't do that. He said he invests 7,000, so he invests it, he gives it to somebody. So his principal value, gives it to somebody, is 7,520. His interest rate is 4.3. It's compounded weekly, 52. And again, on the cheat sheet, I don't understand on the cheat sheet why students don't write down. There are 12 months in a year, there's 52 weeks in a year, and there's 26 fortnights in a year. Why not write that down? That's investing it, in putting into it, depositing 40. Okay, and approximately 860 in interest. Okay, so how much is the future value? Alpha solve. Okay. There we go again. Look at that 0 up there. I'm not doing very well tonight, am I? Weekly, how long? Account 3, 2 years. Weekly, 52, because that's the P/Y times 2 years. There we go. Let's go down to future value. Alpha solve. No wonder it hasn't changed. You invested it for no time, and there you go. You've got the same amount back. There you go. Well done. Winner. There's the answer. Now, students got to show that they've approximately that much in interest. So on their normal, on their page, they would write that number down, perhaps round it to 30 cents, and then they would take away what they put in originally. So what did they put in originally? Well, they originally put in the 7,520, and they also put in $40, and how many lots of $40 they put in. So that's what they need to write down. Don't forget, they're not going to get any marks for the answer of 860. They need to show that they got that, but they would get an answer, a mark for 857.30. All right, so that's a 3-mark question, so well worth them being aware of. I think that's Hassan done. See you, Sam. Moving on, Pia. Oh, good on Pia. She's going to invest in a house. All right, so let's see what Pia's going to do. Put them back to 0. She needs to borrow 80,000. We're going to repay it over 7 years. There's 2 options. Calculate the comparison rate for option B. All right, so this one's just a little bit more complicated, but we can set it all up in here, no dramas. So she's going to option B, 6.1
John, just while you're setting that up, I think it's really good that you're going through and putting in the zeros and the ones back in there. Because I know my students last year, quite often if they already had values put in their TVM solver, they would forget to change them. And so I think having the zeros and the ones in there is really good skill for the students to do in the exam.
Yeah, thanks. Yeah, and I really like them having that template. Perhaps they could have it on their cheat sheet that they then write down on the side of each question in the exam. I just think that
definitely
adds that security as well. So yeah, thanks, Rizzy. Thanks for the confirmation. So we've got 7 years, compounded monthly. The principal value, they need to borrow. So they're borrowing, so they're going to borrow that money. So they're going to borrow 80,000. Now they borrow 80,000, but they've also got to pay a setup fee of 200. So again, maybe what's useful, like we mentioned about highlighting these, is when they've used these numbers, perhaps they put a line through them and say, okay, I've got it highlighted, now I've used that, cross it out, use that, cross it out, use that, cross it out. I haven't used that, where's that going to go? Oh, well, I borrowed 200 as well on that. At the end of that time, I want to owe nothing, so that's okay. So what is my payments? I love doing this topic with students. They freak out when they see how much they actually have to pay back and how they're going to work that out. They go, oh my Lord, how is that actually possible? So then they study harder. That's the idea. But they've also then got a monthly fee, so we need to put that onto that. Just be a little bit careful because it's a negative, so it's going to be minus another $7. That takes it up to that. That's what they're actually going to end up paying per month. And what are we actually working out? The comparison rate. So now we come up to the interest rate, alpha solve, and the comparison rate is 6.33. Moving on, and almost finished these questions. And only the bank that offers A has been approved for a loan. So she borrows 80 grand, 6.2. So let's go back to 80 grand. Is he right? Should change them back to 0. So let's hope I don't make a mistake. At 6.25%. Oops. There we go. Still for 7 years. So let's just check that was the right number again. I think it was 7 times 12. There we go. Perfect. Show that our minimum monthly repayments is about that. So that looks okay. Alpha solve. There we go. So again, students would write that answer down, 1,178.30, which is approximately that. Remember, they're not going to get a mark for this, but they will get the mark for writing that down and all the calculations prior. Why is it a show that? Well, it's a show that because they need to use it in the next part. Probably. I think they discuss it in the next part. Okay, yes they do. So they need to now, so there's a show that and another show that. So there's double show that's here. Okay, so now show that Pia's outstanding debt 3 months after taking out the loan will be approximately that. Outstanding debt after 3 months. So she's paying that per month, she borrows that, so it's only 3 months in. So alpha solve, and there we go. Again, that's the number the students would write down to say that it's approximately equal to that. So this show that is used to help us do this question. Why is there another show that? Well, because that show that is used for the last time. At this time, Pia sells some furniture. So at this time, she sells some furniture, deposits money into the offset account, which is attached to a loan. If she continues to pay, how long will it take her to pay it off? Right, so this now becomes her present value. Again, we could actually type that in up here, okay, but we can actually just be a little bit quicker about that, and we can just arrow up and back into apps, back into finance, cross the bars, and that's her future value. Did you use this with the students, or do you get them to type it in?
No, I got mine last year to type it in, but I'd probably use that instead if I was teaching general again.
Yeah. All right, so we're on to part 2. All right, and she pays, now that's obviously, I've got that as a loan, so that was a positive before, so I need to delete that and put it back to a positive again. And we got some more money off that, so that's, I owe still that, because I got it as a loan, but I've paid some money off what I owe, so I'm going to get rid of that. So I owe less than what I owed before. So there we go. That's less than I owed before. QE. Always nice to pay some money off the mortgage, as we know. This is not going to change. future value now is going to be 0. And if we alpha the time period, it's 75, which is really, so we say to students, even if that was a decimal number that was lower than 5, obviously it'd still be 76 months. Is it months? Yes, it is. Why would it still be 76 months? Because it's still, it's 5 months you haven't paid it off. You need to go into the next month to pay it off. You just won't pay all of it, but you still take 76 months to pay it off. And then the last question is calculate approximately how much interest will be saved. Well, we've actually saved, it was 84 months, sorry. We got rid of 3, that takes us down to 81 weeks, and now we're down to 76 weeks left. So we've saved 5 months of payments. So what we could do is we could come out of this app, and it does say only approximately, so we don't need to stress too much, and it's only the interest, don't forget. So we're going to quit that. We're going to do 5 months of the interest. So if we want to be really picky, we could go into apps, into finance, cross the bars, and the payments, and get the answer. But it did say only approximately, so up to you for your students. It's obviously not a negative because that's what we had, or you can leave it as a negative, but we did actually pay off the 4,000 on that. So that's actually what we would actually, the interest only, and it says that on the examiner's report as well, it was only interest in the interest. That is what we save. And there we go. Woo! Izzy, we smashed it.
We sure did.
Any other questions that came up while I was presenting that, apart from they couldn't see my screen at the start?
No, that was the only one.
I could see it. I was really enjoying what I was seeing.
Yeah, no, it looks good the second time around as well.
So if you do have any last-minute questions, please try and get them asked. I know Izzy will be monitoring that now as we speak, and we will endeavour to answer them, or we will add them to future webinars. When you do leave tonight, there will be a brief survey that will automatically appear in your browser, and your feedback does guide us as you plan for future honour events. We do listen to your feedback, so we hope you share your thoughts in a post-webinar survey. Your certificate of attendance will be emailed to you in the next 48 hours, along with a link to the on-demand and YouTube versions of the recordings, as any relevant documents that we showed tonight. And those, please, make sure you share with your colleagues, but also I think that a lot of these, this one, the one that we did on Tuesday, for methods, is useful to share with our students as well. After we leave tonight, if you do need some post-webinar follow-up, please feel free to phone or email us. We'd love to hear from you. And sadly, that brings us to the end of tonight's webinar. Izzy, thank you very much for everything you've shared with us tonight. I'm sure the participants, from what the feedback I had, have really appreciated it, so thank you.
Pleasure.
And likewise, thank you, everyone, whether you're watching us live tonight or whether you're watching on demand. Thank you very much for watching this. I hope you found it beneficial. I hope you get a lot from it, and I hope your students get a lot from it too. And on that note, thank you and good night.
Bye.